An uninterrupted series of satellites has collected sea level measurements for nearly 30 years. And now a joint U.S. European effort will launch the next spacecraft to carry on this legacy of monitoring sea surface height. We are here today to count down the launch of the Sentinel-6 Michael Freilich satellite that is less than a month away and answer your questions later in the briefing. This has been a true collaboration among several agencies, which you will see represented today. In a first joint Earth mission involving NASA and the European Space Agency, this Sea Level Scout will collect the most accurate data yet on sea level and how it changes over time.
This is this big, complex machine that we're trying to understand.
We really need to understand how it's changing. How is it evolving?
Wherever you live on this globe, the oceans will influence you in some form or the other.
We are answering those really interesting and hard questions that we all have about our universe and our planet.
And my name is Séverine Fournier, and I'm observing our changing oceans from space.
I'm Shannon Statham, and here at NASA JPL, I help prepare Sentinel-6 for its journey to space.
My name is Shailen Desai.
My name is Parag Vazay.
My name is Ben Hamilton, and I'm studying sea level rise from space.
We're looking at a one-third replica of the Sentinel-6 Michael Freilich satellite.
Sentinel-6 is all about water.
This sort of top half of the satellite houses the main instruments.
We have the altimeter, we have the radiometer.
Sentinel-6 is a collaboration with NASA, NOAA, the European Space Agency, and also EUMETSAT in Europe to measure sea level.
And it's specifically capturing the height of the ocean.
The satellite is actually emitting a signal.
And that signal is bouncing back.
It measures the time it takes for that pulse to get back.
So we've been measuring the height of the ocean since the beginning of the 90s.
I've worked on Topex Poseidon, JSON-1, JSON-2, JSON-3.
We really need that long duration observation.
And Sentinel-6 is going to allow us to continue that record
so that we can better predict what is the rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It's not just scientific curiosity. It really impacts the daily lives of people and their ability to plan for their future.
I see pictures of coastal inundation and flooding.
You start to realize the importance of understanding what sea level is doing now. We can use that understanding to know what sea level might be doing in the future.
Seeing that come to fruition is a personal satisfaction and an emotional satisfaction.
Scientists around the world are using this data to help people.
The importance of this project and where it touches is on all walks of life all across the world.
From space, it's just one planet.
Welcome. I am Marina Jureka from NASA's Jet Propulsion Laboratory in Southern California. I am your host today as we bring you a closer look at this incredible mission that will continue to help us understand how our oceans are changing. As we are social distancing, I will introduce you virtually to some of the people behind the Sentinel-6 Michael Freilich satellite. We are experiencing a bit of an audio delay with our European partners, so please be patient with us. On our panel today, we have NASA's Associate Administrator for the Science Mission Directorate, Thomas Zurbuchen, who will talk about NASA's dedication to Earth observations and the legacy of Michael Freilich, whom the satellite was named after. The European Commission's Deputy Director General for Space, Pierre Delceau, who will speak about the legacy and commitment to Earth science missions through the years. European Space Agency's Director of Earth Observation, Joseph Aschbacher, will tell us about the agency's Copernicus program, the European Union's Earth observation program, which monitors our planet and its environment for the ultimate benefit of its people. NASA's Earth Science Division Director, Karen St. Germain, will discuss the benefit to humanity in understanding and studying the Earth and the importance of what Sentinel-6 Michael Freilich will show us. Director General Alain Ratier of the European Organization for the Exploration of Meteorological Satellites, or EUMETSAT, who can talk about how this organization will carry on day-to-day operations of science gathering for the satellite. Project Manager for this mission, Parag Vazay of NASA's Jet Propulsion Laboratory, will talk about the legacy of these Earth-observing satellites, starting with Topex Poseidon almost 30 years ago. NASA's program scientist for this mission is Nadia Vinogradova-Schiffer, who will break down the science goals and what the mission hopes to accomplish moving forward. And finally, Tim Dunn, the NASA launch director for Sentinel-6 Michael Freilich, who will give us an update on launch status as we count down to November 10th. For anyone watching who would like to submit a question, you can do so by using the Seeing the Seas hashtag. Our phone lines are now open to the media. You can ask a question by pressing *1 to be put into the queue. We will begin with NASA's Associate Administrator, Thomas Zurbuchen, at NASA headquarters in Washington, D.C. Dr. Z, welcome. This project has been such an incredible international collaboration, which is appropriate since all the oceans unite us all.
Thank you, Marina. Indeed. We live on a blue marble flying through space. And it's blue because of the 70% of the surface that's covered by oceans, and of course, primarily because of the Pacific, Atlantic, Arctic, and Indian Oceans. What we tend to forget, though, and the movie reminded us, that nearly 80% of the Earth's population lives near oceans, and 90% of all commerce internationally crosses the seas. So the oceans are part of every one of our lives. And frankly, this focus on the oceans is very appropriate. It's the last great frontier, I would believe, of discoveries on Earth. And very exciting to learn new things for us from that investigation, which is a first European partnership of this type for NASA with ESA, and we couldn't be more excited. So I'm so glad that this new satellite, the Sentinel-6 Michael Freilich, will go into space and really teach us about this, blue marble, our home, the most beautiful planet we know about. It can teach us about climate change, about weather, and continue that 30-year record that was accomplished by an international community. Just how the oceans are global, so is the community that needs to study it. And so with this spacecraft and with Sentinel-6B that will be launched in 5 years, we will add another 10 years to this amazing record of international collaboration and impact. We work together as an international community, and we do so because together we learn best. We have one science community on Earth, our international community, and also together we can provide best the information to all decision makers about critical decisions they need to make in the future. I want to tell you, I'm so honored have been part of a ceremony earlier this year to name this satellite after Dr. Michael Freilich. Frankly, Mike is no longer with us, unfortunately, but we will never forget his deep knowledge, how forthright he was, how strong and focused on always doing the right thing. And then, once that's decided, is on doing things absolutely the right way. Mike taught all of us. I consider myself a friend of his, and I'm just so glad to know that this trust that we have and had in Mike's work was also a trust that was shared all around the community. That trust and his understanding of the importance of that international partnership at the basis of Sentinel-6 Michael Freilich led to this unprecedented honor of his name being on the spacecraft today and up there on the launch vehicle. You saw the fairing with his name on it. And I just want to tell you, I'm still moved just thinking how I felt when I received that email from our friend Josef Aschbacher, co-signed with multiple colleagues from Europe now on this call that proposed renaming this in Mike's honor. And I'm just so glad to be here with our European colleagues, all of them. And I'm glad to turn it over to Mr. Pierre Lassault, the Deputy Director General of the European Commission. Thank you.
Thank you very much, Thomas. You know, we all live in a difficult time because of the COVID-19 situation, which affects the US like Europe and the rest of the world. And so in this difficult context, it's a pleasure and an honor to see actually that we are able to have a good cooperation between us and to develop projects like the Sentinel-6 that we are going to launch very soon. And that's important because we have been able to achieve this between partners across the Atlantic with NASA, NOAA, but also on this side of the Atlantic with ESA and EUMETSAT, and of course, let's not forget the industry. This is a perfect example of cooperation between European and between American to achieve a very important goal. Now, as Thomas has said, I would like maybe to focus a bit on the name that we are going to give to this Sentinel-6 Michael Freilich. As he said, Mike was a great man, and I believe it's important for us to have named this satellite with the name of Mike Freilich, because it's a sign not only of the fact that Mike was a great man, but also it's a gesture towards the cooperation which exists between the US and Europe in the field of space. And I believe that's important that, you know, for a very long time, these satellites will move around the Earth with such a name which represents so well this achievement. Now, as you say, this is Sentinel-6 will be part of Copernicus. Copernicus is a European Union program, which is an Earth observation program, which of course observes on a worldwide basis. You know, I'm very proud to say that Copernicus is a real European success. It has been built under the leadership of the Commission, but of course with a real partnership from ESA and EUMETSAT, and of course the European industry. Sometimes, you know, Europe is being criticized for not being able to work together, but Copernicus is an excellent example of cooperation and work between everybody in Europe to achieve a system which is excellent and provide a lot of information. The second message I would like to give about Copernicus is the fact that Copernicus is a global program. Of course, it's run by Europeans, but the purpose of Copernicus is to serve the whole world, the whole planet. And we really want that data which are available, which are given by Copernicus, are available for everybody across the world. And we don't hesitate when it's needed, actually, to provide it even to the US. For instance, we have done it during the hurricane season. Because, again, we believe that it's a powerful tool, and everybody should be able to benefit from this powerful tool. Third element I would like to say about Copernicus is the fact that for us, Copernicus is a very important element in monitoring the situation of the Earth, and more precisely, to achieve what we call in Europe the Green Deal. We cannot ignore that our planet is changing. You know, I live in Brussels. I can tell you the weather in Brussels is no longer the same that it was 10 years ago, 15 years ago. It's completely different. We have almost hurricanes during the day, you know, we have a hot summer. So climate is changing. Nobody can deny it. And from that point of view, we need to understand why the climate is changing, what are the factors, and we need also to monitor this situation. And I would say that Copernicus, one of the key roles of Copernicus is to be able to do such a thing, to help us to understand better the challenges in front of us, to better monitor the situation of our planet, and to see what we need, of course, and that could lead to what we need to do to avoid environmental degradation. So Copernicus is a powerful tool. I'm very proud to be in charge of this tool, again, with the cooperation of my colleagues from ESA and EUMETSAT. And we really want this tool to continue and to be a basis for the cooperation, again, in the future with NASA, with NOAA, and of course with U.S. Geological Survey. Again, as I say, this is not a tool for Europe. This is a tool for all of us. Because at the end of the day, our planet is not only a European planet, it's a global planet for everybody, and we need to preserve it. Now, I would like maybe to say a few words about Sentinel-6, not too much, because you already have explained a bit what, what is supposed to be achieved with Sentinel-6. It's a very important element in the Copernicus systems, and Joseph, who will talk after me, will go into the details. Clearly, Sentinel-6 is designed to act for the next decade as a reference mission in altimetry. As you say, monitoring the situation of the ocean is fundamental, is a key element for everybody, because as you say, Thomas, we are surrounded by water everywhere. So it's important that we have a powerful instrument which will be able to monitor this dimension of our planet. And again, we believe that this instrument, Sentinel-6, will be able to provide us useful data, which could be incorporated in models And combining Earth and atmosphere observation, we'll be able also to use it for regional weather forecasting. And we believe this is extremely important because of the different elements I've already mentioned. But again, my colleagues from ESA, NASA, and EUMETSAT will talk much better than I could do about this. But again, the message is clear. We believe that Sentinel-6 will be a powerful tool in helping us to better understand the situation of Earth, of our planet. Now, as a conclusion, again, I would like to thank all partners to be able to achieve such a great program, to make sure that the launch will be on time. And honestly, as I said, coming back to my first point, it was certainly not obvious in the context of the COVID-19 situation, which has affected everybody. So again, I would like to thank everybody, all the efforts which have been done to achieve this. And again, by working together, we give a strong signal to the rest of the world. And now I would like to give the floor to Joseph Aschbacher from ESA, a strong partner in this enterprise.
So thank you, Pierre, and welcome also from my side. So thank you for this introduction and also the words of explaining how the Copernicus cooperation is working across the Atlantic. And I really would like to say that many would claim that Copernicus is an excellent cooperation where Europe works extremely well together in space. Yes, that is absolutely true. But in this case, it is also a symbol for the excellent cooperation between Europe and the United States of America. And I think this is really showing, and as it was mentioned also before, how powerful and how wonderful this satellite is to prove this cooperation. So what you see here in this slide is taking the pulse of our planet, which is really the slogan which we are using in Earth observation in ESA, where different satellite sensors are measuring different parameters of our planet, of the atmosphere, of the oceans, of the land surface, of the cryosphere, but in particular to understand how these elements work together, how they are interconnected, and certainly in order to better understand our planet as a planet, but also the life on our planet and how we can protect it in the best possible way. If we go to the next slide, it shows the portfolio of Earth observation satellites, which we are currently developing in Europe through the European Space Agency. Copernicus, you see here on this picture in the middle, which is the orbit with the most crowded space of satellites. Michael Freilich, Sentinel-6 is somewhere in the middle. Copernicus is led by the European Commission, as Pierre was just explaining. And the European Commission really defines the policy priorities, the user requirements, but also gives the majority of the funding and the leadership overall of Copernicus. And I'm very happy to see a very strong leadership of Copernicus by the European Commission, which is really essential to have the program in place. Then you see on the right-hand side our partner EUMETSAT. With EUMETSAT, we have a long-standing, several-decade-long cooperation on meteorological satellites, geostationary and polar orbiting satellites, and Alain Ratier, the Director General of EUMETSAT, for sure will later on explain the context of Sentinel-6 and the meteorological measurements. But here, just to say that also on our side with ESA, I'm very happy to see and very happy to state that the cooperation with EUMETSAT is actually, in one word, excellent. Then on the left-hand side, we see science. Science missions are the satellites that answer to burning questions of science, but with the latest technology, and really novelties in terms of satellites that are being developed to address questions that are leading to a better understanding of our planet. We call them Earth Explorer missions, and there are several in orbit already, and others are being developed and being made ready for launch in the near future. Altogether, today we have a portfolio of 40 satellites under development, 15 in operation, and another 13 in preparation. And this is by far the biggest portfolio which in Europe we ever had. On top of this, we also have satellites missions from our member states which complement the European portfolio. And I think this is important, that this is a contribution that Europe collectively provides to a better understanding of our planet. And the next slide shows a bit the Sentinel series of satellites. You see on the right-hand side different numbers, Sentinel-1, Sentinel-2, all the way down to Sentinel-6. And they're having different instruments on board, a radar instrument, multispectral imager, an altimeter, atmospheric chemistry instruments, and as you see here at the bottom, Sentinel-6 with a very precise altimeter to measure sea level across the oceans. And these satellites, today there are 7 of those in orbit. They are producing at the moment 250 terabytes of data, which we are disseminating to the world, to all the partners who want to retrieve this data. And I should say that these 250 terabytes of data which are coming out of our servers here in Frascati is only the tip of the iceberg, because thanks to a free and open data policy, anyone can disseminate this data, and there are many mirror sites across the globe which are replicating and redisseminating this data. So these data are really entering all levels of society, at the institutional level, at the commercial level. They're really finding a very deep way into the various segments of a better understanding of our planet. The next slide shows one of these examples where these data are being used. Obviously, today we talk about Sentinel-6 Michael Freilich. That means altimetry. You see here the measurements of global mean sea level across the oceans from 1993 onwards. In fact, the first measurements date back to 1991 with Topex Poseidon and ERS-1, both satellites that have been put together by Europe and the US. And all the way over these decades, different satellites have provided a piece of this curve for these measurements in order to be sure that we do well understand the sea level rise globally, but also the variations on different places on our planet. What you see here, of course, is also alarming. On the left-hand side of this curve, in the 90s, the sea level rise is 3.1 millimeters per year, and towards the right-hand side, in the 2010 years, you see an increase of 4.8 millimeters per year. And this is not a linear increase, but an asymptotic increase, and this, of course, is very alarming, because this means that the sea level rise is accelerating over time. Scientists are expecting that by the end of this century, the sea level will have risen by about 1.3, 1.5 meters, depending a bit on the models and the different assumptions. But in other words, we do need these satellites to make these precise measurements and to well understand what is the impact on our planet. If we go to the next slide, you see a picture of Copernicus Sentinel-6 Michael Freilich satellite, and this is really a small miracle and a fantastic satellite which we have built together. And together means really the United States, and I should really acknowledge the enormous effort the United States were making, both on the side of NASA but also on the side of NOAA, in order to make this satellite a reality. And of course, on the European side, with the European Commission leading Copernicus overall, with EUMETSAT, with CNES, and also with our own organization, European Space Agency, who has been essential in putting this satellite into place. As you know, the satellite will launch in less than a month's time. In fact, today's event is called L-30, indicating that it's 1 month before the launch date. And as you will notice, today is the 16th of October, but the launch is planned for the 10th of November, meaning that we have actually put the launch earlier than originally planned. A year ago, we had a plan for the launch around 15 or 16 November. So this also shows that the satellite has been on time, and on time not only since a year, but since a few years. We have been indicated a November 2020 launch date a few years ago already, and we have kept this launch date to the day. In fact, we have advanced the launch date by 5 days. And I think this is also proof of the engineering capability, but also the excellence of industry and project management, who have all worked together to make this happen. The satellite itself weighs about 1,400 kilos, has a nominal lifetime of 5.5 years, flies at an orbit of 1,366 kilometers with an inclination of 66 degrees, and has as a main instrument Poseidon 4, the radar altimeter, which is a very, very precise altimeter in space, plus the AMC radiometer provided by NASA, the GNSS POD provided by NASA, and the DORIS provided by CNES. The next slide will go a step further and show a bit the US European cooperation, which we have since many, many years. And this really is showing just a few acronyms, and they may not be easily understandable. IMBI stands for mass balance experiment, which we carried out together with US and European scientists to really study the mass balance of Greenland and of Antarctica with all the sensors and all the measurements we could take to determine the truth of how much is melting or how much is accumulating on certain areas. And this was a fantastic work over a couple of years where the best scientists on both sides of the Atlantic have been putting together data models to have a better understanding. But you also see JPPG, which is a joint program planning group between NASA and ESA, where we work on different domains. And in fact, in one word, this cooperation which we have built up through Sentinel-6 Michael Freilich is such a wonderful cooperation, and I really would like to thank my partners in NASA who have been so committed to make this happen that we have decided that we want to further explore this cooperation on new missions, and you see a few acronyms here on few candidates which we are studying right now, where ESA, NASA, but Europe and the US in general can work closer together. And I think this is really a testimony of the strong cooperation which we have and the strong partnership which we have developed over time. And the next slide really shows the man who has to be honored today, Michael Freilich. Michael Freilich, also as Thomas was already saying, has been an incredibly strong scientist, a very strong believer in the truth. He has always told what he thinks, but he has been a brilliant scientist and really a good friend and a good partner in many aspects. You see here we have handed over the certificate to name the satellite after him. Very, very unfortunate that he cannot push the button at the launch pad next month to see the satellite flying into space. It makes me really feel sentimental when I think of it, but Michael Freilich was a friend, was a partner, but he also left a big legacy of international cooperation, and I really would like to thank the US for having allowed this cooperation to materialize, which Mike was putting in place. And let me show the next slide, which is just a slide to thank all the partners involved in this cooperation in the US, in Europe. This has been a unique experience, and I'm so grateful to everyone for their contribution. And I would like to thank you from my side and hand over to my dear friend and colleague in NASA, Karen Saint-Germain, the director of NASA's Earth Science Division.
Thank you so much, Joseph. It's a thrill for me to be here today, still new in my role as the NASA Earth Science Director and sitting a month out from the launch of the Sentinel-6 Michael Freilich satellite. The Earth is a global system of intricate and dynamic interactions between ocean, land, ice, and the atmosphere, and also human communities. And that global system is changing. And increasingly, decision makers in the public sector and the private sector at all levels are turning to the earth science community to understand those changes, to inform, frankly, both the risks and the opportunities about which they have to make critical decisions. We in the earth science community seek to advance our understanding and ability to model and predict that Earth system, and it's the observations, and in particular from satellites, that underpin our ability to do that. NASA has a fleet of satellites that observe all aspects on different time scales and different spatial resolutions of the Earth system. And Sentinel-6 Michael Freilich will be the newest addition to that fleet. As Joseph explained, this satellite will continue the decades-long record of observations of sea surface height. But it's when we use the observations from the altimeters in combination with our other satellites that we really unleash the power of these observations. For example, when we combine the altimeter observations with gravity measurements, we can actually sort out where the increase in the sea level is coming from, how much of it is attributable to melt of ice sheets and glaciers, and how much of it is attributable to the expansion of the ocean itself as it warms up. When we combine altimetry with synthetic aperture radar, we can make better. We have a better understanding of the relative sea level rise in our coastal communities, because we can take account of what the land surface itself is doing. And when we combine altimetry with the observations we get from weather satellites, We can do things like better predict rapid intensification of hurricanes. When a column of seawater warms, it expands, and that creates a bulge on the surface that we can see with the altimeters. And when hurricanes pass over these warm bulges, that's when we get rapid intensification events like we saw with Hurricane Michael in 2018, and we are seeing them play out again in the hurricane season that's still ongoing this year. And we do all of this, as you've heard, through international partnerships, not just to maintain the continuity of observations, but also to advance them. And you'll hear more about all of that when our program scientist Nadia speaks in just a few moments. This mission, Sentinel-6 Michael Freilich, is especially meaningful to me for two reasons. One, it was back in 1992 that as a graduate student, I got to make a small contribution to the calibration and validation of the very first, the Topex Poseidon altimeter. But more importantly, this mission bears the name of my friend, colleague, mentor, and my predecessor as the Director of Earth Science, Michael Freilich. Michael was a driving force in establishing and maintaining the partnerships that enable all of the earth science work we do today. So with that, I'm looking forward to the launch in a month, and I will turn it over to my friend, the Director General of EUMETSAT, Alain Ratier. Thank you.
Thank you very much, Karen. Yes, so EUMETSAT and NOAA have been involved in the JSON success story since 12 years now, starting with JSON 2. And the involvement of both operational agencies acknowledges the operational maturity of ocean altimetry and its unique value for ocean prediction and monitoring of mean sea level. Ocean prediction is essential as such for our blue economy, but it's also a key component of coupled ocean atmosphere prediction. And thanks to this data, so this coupled model, we can predict that the current hurricane season is exceptional in the Atlantic. So with Sentinel-6, Michael Freilich will continue a unique climate record, an undisputed climate record, repeating exactly the same orbit as Topex Poseidon and the previous JSON mission. We will also deliver the most accurate measurements of sea surface height, against which other altimeter mission will cross-calibrate. On this slide, you see that Sentinel-6 is part of a broader constellation, including also two Copernicus Sentinel-3 satellites flying on different complementary orbits. On this picture, you can see in white the altimeter ground track of Sentinel-6, and in blue the ground track of one Sentinel-3 satellite. And what you can see, in fact, the ground track of Sentinel-6 have a broader separation, but they repeat much more frequently every 10 days. And this is optimum for monitoring the tropical ocean, where changes are faster at larger scale in direct response to the change of the wind field. And this is where El Niño starts. So El Niño is, as you know, one of the major climate features having impact on our planet. Next slide, please. So the role of EUMETSAT has significantly expanded from JSON to Sentinel-6. We coordinate the system activities across the partners, and we also develop the core ground segment under our own program. And on this picture, you can see our staff in Darmstadt during satellite validation tests, so where our ground segment talks with the satellites, and you see two pictures because in the COVID-19 times we had to split the team in two for social distancing, but as previous speaker said, we all made the required effort to keep ready for the launch. Next slide, please. We also preparing ourselves to take over flight operations from the Sentinel-6 Michael Freilich satellite 3 days after the launch from ESA. And we will then operate the full system in cooperation with our European and US partners. And what you can see here is our new mission control center, the Copernicus Mission Control Center, from which we will operate both Sentinel-3 and Sentinel-6. So I wish to thank all our partners from Europe, from the US, for their trust and also for the excellent cooperation. And as Michael Freilich said, go Sentinel-6. And I'm now very pleased to pass over to my friend Dr. Parag Vase, who I think, like me, has been involved since Topex Poseidon in the full series of missions, and I certainly a lot of things to tell you. Parag, you have the floor.
Thank you. So my name is Parag Vase, and I'm really honored and privileged to be able to work on this incredible mission called Sentinel-6. It's a global partnership, as you've heard, and we are working very, very closely together to make this mission a reality. Measuring the world's vast oceans is a difficult problem. We have to cover a vast amount of space and to do it very, very quickly and measure the world's oceans very accurately. So naturally, satellite technology is a very good solution for this problem, but as I think about it, having a satellite that's orbiting 800 miles up, spinning around the Earth at 5 miles every second, and now being able to do a very accurate measurement of the sea surface height to within just 2 inches is an incredible feat, and one that if you'd asked me years ago, I would have said people are crazy. But this is exactly what all of our teams have been doing for the past 28 years with the start of the Topex Poseidon satellite and subsequent JASON series of missions. And now with the Sentinel-6 project, we're planning on continuing that for the next decade, and in some respects even doing it better. So let me show you an animation that describes a bit about the satellite. The satellite is provided by ESA with contributions from NASA and is built by Airbus in Friedrichshafen, Germany. The Sentinel-6 Michael Freilich satellite is built to operate for at least 5 years, 5.5 years, and has a twin that's expected to launch in 2025 to really be able to extend this for the next decade. The altimeter that's provided by ESA measures the sea surface height by sending microwave pulses down to the ocean and measuring how long it takes to reflect that pulse. You can see that in this animation with the red signal that's bouncing off the ocean. However, as the signal travels through the atmosphere, it slows. So we have a NASA-provided microwave radiometer instrument shown with the blue beam that measures the delay to improve the height accuracy. We also need to know precisely where the satellite is, so we have instruments from ESA and NASA that use GPS and other tracking systems to know precisely where the satellite is located. The satellite is running 24 hours a day, 7 days a week, doing ground track measurements of about 30 kilometers each, but over the span of 10 days, we're able to build a map of the complete world's oceans. So if we can go to the next animation. But as a bonus on this satellite, NASA is providing a radio occultation measurement instrument that provides measurements of the Earth's atmospheric temperature and humidity profiles. This is a very important measurement for the world's weather agencies and is done by measuring how signals from existing satellites, like GPS satellites, are bending as they cross across the Earth's atmosphere. Now for Sentinel-6, we have a few additional features that we are enhancing. Sea level, as said before, is rising, but it is also accelerating, and understanding this acceleration is even more important for the future, and having very precise and stable measurements is key. So the new NASA radiometers and ESA altimeter have enhancements that improve that stability, accuracy, and resolution. If you can go to the next slide. The altimeters and radiometers feature higher resolution to get much closer to the coast, as illustrated by these red hash marks, which we haven't been able to see before with these types of measurements from our existing satellites. As you know, a vast majority, hundreds of millions of people across the world live on these very, very close coastal regions and who are directly affected by the sea level rise. So doing so, this is a global problem and a global challenge, and we're bringing together a global solution. As you've heard, we are bringing together engineers, scientists, and agencies from across the world to collaborate on this important mission. And we're doing this very actively and in a very successful manner. We are really indebted to Michael Freilich, Dr. Michael Freilich. This was an important theme that he has stressed on all of the people that he has been working with for many generations, I being one of them to have been lucky enough to have worked with him for many years over these past missions. Dr. Freilich, we're building this satellite in your honor and implementing it in that spirit of collaboration. And we're planning on doing this, of course, on this mission, but continuing that for future generations of teams working and collaborations, hopefully continuing well into the future. The satellite, mission systems, ground systems, and importantly, all of the teams across the world are ready. We've prepared for this launch, and we're anticipating a fantastic launch and commissioning of the satellite and start of this important mission for the next decade. So now I'll turn this over to my colleague, Dr. Nadja Vinogradova-Schiffer, who will tell you much more about the program science.
Thank you, Parag. And I agree with you. What seemed like a technological wonder some time ago now is a mainstream instrument in modern physical oceanography and climate science. It enabled hundreds of discoveries, and I'd just like to touch base on a few of them. We talked a little bit about global mean sea level rise, and when my kids ask me, is 3 millimeters a year is a lot, I told them that that equivalent to adding extra 300 trillion gallons of water every year. And if you put this water in milk jars, that would cover the distance from Sun to Pluto and back several times. So that's a lot of water that expanding and creeping to our land. And if you can see from my first animation, altimeters can tell us by how much and where exactly this rate of sea level rise is. And if you can see that the red spot, excuse me, shows us those hot spots on the globe that is indicative of where sea level is rising faster, such as the east coast of the United States. So what does NASA do with this information besides monitoring? We have dedicated science teams that untangling complex physics of sea level, sort of tease out physical processes behind those rise, and then use this collective knowledge to improve projections of future changes in sea level, projections that are data-driven, physics-based. So what can we do with altimeters beyond sea level? Well, it turns out quite a lot. The shape of ocean topography is related to and impacted by a lot of physical processes. So we could tell a lot of physics behind it. One of the examples is, of course, that was already mentioned, ocean circulation. And on my next animation, you can see that ocean is a constantly moving feature, and satellite altimetry record could be directly related to the velocity of ocean circulation. And moving water, as you can see, transfers enormous amount of properties such as heat, momentum, salt, carbon, plastic, oil spills, nutrients. So altimetry data is our key informational constraint in climate models and ocean state estimates, as well as operational forecasts, including weather prediction that Karen already mentioned. In the next graphic, you can see an example of what the surface, sea surface height looks like other than trends. And you can notice those hills and valleys, or higher and lower sea levels. That tells you exactly what's happening inside the water column. In fact, altimetry is our only ocean surface measurements that we make that we can connect to the physics of the whole water column, and which is key in predicting hurricane intensity. But going beyond extreme events like hurricane, we can also look at interrennial variations such as El Nino and beyond. As we're extending our altimetry records into the fourth decade, we could look at the climate mode of variability on a spectrum of frequencies. Finally, my final example that I'd like to mention today is how altimetry completely revolutionized the way we looked at tides. Essentially, altimetry solved our multi-century problem of surface barotropic fast-moving tides. But what was really surprising is the recognition and detection of the internal tides when the surface tides encounter a bottom topography or sloshes over a mountain. It creates the internal fluctuations that could be high in range, hundreds of meters, and only a few centimeters at the surface. And as Parag said, with our highly accurate measurements, we can detect those internal fluctuations from the surface. And those internal waves travel for thousands of kilometers and transport a large amount of energy. They connect us to a history of lunar orbits, but also tell us about the Earth climate and energy dissipation. And this is an ongoing and active area of research that Sentinel-6 data would help us to uncover more, as well as problems to solve with a future next generation NASA altimeter mission like SWAT. So I'm going to leave you with a little teaser here today and turn to our next speaker, Tim Dunn.
Thank you, Nadia. Good morning from the Kennedy Space Center. My name's Tim Dunn, and I am very proud to be the launch director for the Sentinel-6 Michael Freilich mission. And I'm even more honored to represent the men and women of Launch Services Program. LSP is NASA's program that acquires the launch services or the rockets for many of our agency's most critical spacecraft. So LSP has a legacy with the Jason series of these ocean topographic satellites. All the way back in 2001, we were proud to acquire a Delta II to launch that spacecraft. And about 7 years later, for the OSTM mission, which became the Jason II spacecraft. And then just 4.5 years ago, I was really thrilled to get to work with my friend Parag Vazai from JPL and launch the Jason III spacecraft on a Falcon 9 rocket. All three of those missions launched from Vandenberg, and so our program is based here at Kennedy Space Center, and we were proud to execute a launch campaign just this past summer in the midst of this pandemic that we're in with the Mars 2020 campaign. Had a successful launch at the end of July, and now we and LSP get to take our talents on the road and head west to Vandenberg Air Force Base while still in this socially distanced environment of a pandemic, go launch a beautiful rocket with an amazing spacecraft from the Central California coast. So here we are 25 days from launch. Things are going incredibly well in the launch campaign. All of the launch vehicle hardware for the Falcon 9 rocket is at Vandenberg. It's at SLIC 4. SLIC stands for Space Launch Complex, or the launch pad. So we're right there on Vandenberg Air Force Base, and all of the hardware is being processed in a pre-launch manner by SpaceX. It's incredible to work with SpaceX as a company. They bring together incredible talent to our industry, and we are just so fortunate to be able to get a ride with them on a Falcon 9 rocket. So there in the hangar at Slick 4 at Vandenberg, not only is the rocket present and undergoing pre-launch processing, but on the other end of the hangar in the payload processing facility, the PPF, is that precious cargo that the Falcon 9 will launch, the Jason 3 spacecraft, the Sentinel-6. So all is going really well. Our team has begun to deploy. The core portion of our team is going to deploy out to Vandenberg within the next 2 weeks. We're going to all assemble there at Vandenberg. We're going to have a series of reviews. We're going to practice countdown leading up to launch, and it's going to culminate in an incredible event on the 10th of November. And I want to stress that our team remains on track. All of the hardware processing for both the spacecraft and the rocket is on track to support that 10 November launch date. At about 11:30 a.m. Pacific Standard Time, excuse me, because we're going to transition our times. We're going to have a beautiful launch from the Central California coast. And that's all I have. I'd like to turn it back to Marina.
Thank you so much, Tim. We are all in eager anticipation, as you can see, for that November 10th launch across the globe. We are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of the panelists. We're also taking questions through the Seeing the Seas hashtag. And remember to be patient. We do have a little bit of delay with our European partners. So our first question comes from John Amos of the BBC. Good morning, John. John, are you with us? John Amos from BBC.
Yeah, I hope you can hear us here in London. And my question is for Nadia. I've heard it said that Sentinel-6 will bring such precision to measurement that it will be able to see some of the most subtle effects of the increase of greenhouse gases on the atmosphere. I'm thinking the way that it affects trade winds, and obviously that then has an effect on sea level. Can you explain that to me?
Yes, thank you for your question. There was a Sentinel-6 continues the legacy of high precision measurements, and in addition, this way around, there were additional improvement to the accuracy of the sea level measurements, including the limiting calibration drift to keep it under 1 millimeter per year level. That would truly allow you to distinguish even the slightest millimeters to sub-millimeter signal in the data, such as sea level trends and acceleration, emerging acceleration that we talked about it today.
Thank you, Nadia. Next is Elizabeth Howell of space.com. Good morning, Elizabeth.
Good morning. Thanks for your time, everybody. So you've already hinted at some of the distinguishing features of Sentinel-6. This is probably more for Parag or Nadia in terms of the science that it can perform. You were talking about measurements at the coast. You were talking about looking at the underground or underwater sort of waves. What other ways, what other kind of new science do you anticipate that Sentinel-6 is going to be bringing after it launches? Thank you.
Nadia, do you want to take that?
We anticipate, first of all, this is we are excited to have a longer almost 4 decades of continuous and uninterrupted climate records. Climate is inherently a large-scale and long-term processes. So some events taking a while to unfold. So having a long and consistent climate records is key to our robustness of understanding of those processes that happen on a longer time scales. You mentioned improved resolution along the coasts and in the open ocean. So we are excited to see how those energetic features such as mesoscale eddies that shed over the currents evolve and propagate and change our circulation and affect our weather and climate.
Thank you, Nadia. Our next question is from Stephen Clark of Spaceflight Now. Good morning, Stephen. Stephen Clark, are you with us?
Hello, can you hear me now?
Yes, we can hear you.
Okay. Stephen Clark from Spaceflight Now. My question is for Tim Dunn. I know NASA is looking at a gas generator issue on the Falcon 9 as they evaluate when the Crew 1 mission can launch, commercial crew mission can launch. Your mission is still scheduled for Sentinel-6 on November 10th right now. Have you studied that issue? What have you found? Have you found that it's not an issue for this particular vehicle? And what can you tell us in some terms of background of what the issue actually is that you assess? Thanks.
Thank you, Stephen. So 2 weeks ago today, there was a GPS spacecraft on the pad at Complex 40 here at KSC, Cape Canaveral Air Force Station, and it experienced a launch abort in the final seconds prior to launch. And that was the Falcon 9 rocket stopping itself from launch when it sensed things weren't right during the engine startup sequence. So after that anomaly occurred on the pad, the GPS spacecraft is absolutely safe and it will launch successfully when the Space Force team is ready. But the joint government community came together alongside SpaceX in an investigation team to look at that engine issue that prevented the GPS from launching 2 weeks ago. So that team consists of folks from the U.S. Space Force, from our program, NASA Launch Services Program, working alongside SpaceX and their engineers from Hawthorne. And I can tell you an incredible amount of data has been looked at, to include members from our commercial crew program, which also has an upcoming Falcon 9 flight. And so that investigation is ongoing. There's been a tremendous amount of testing that has occurred here at the launch site on the East Coast. The engines have been taken back to McGregor, Texas, which is where SpaceX does detailed engine testing and reviews. So those engines have been further tested there. And it's just an amazing team that is looking at this issue. We've learned a lot. There's going to be some hardware implications as we move forward, depending on the engines installed on various rockets. The GPS mission obviously is affected. The NASA Crew 1 mission is affected. We on Sentinel-6, we are looking at the engines that are on our first stage Falcon 9. We're going to work through what we need to do, but as of today, we have a path forward that allows us to do whatever necessary rework may be required and still maintain that 10 November launch date. So while it's an issue that's being addressed by multiple agencies, multiple customers, SpaceX has been incredible in working this anomaly and bringing all of us in together. And so we are looking forward to that clear path that gets us to 10 November, Stephen.
Thank you so much for that, Tim. Now we're going to turn to some social media questions using the hashtag #SeeingTheSeas. Frank on Facebook asks, where have the oceans actually risen and by how much? Nadia, would you like to take that?
Yes, you've seen on one of my animations this rotating globe that's showing you exactly how much and where the sea level is rising over the past 3 decades. The graphic shows that there is a lot of yellow and red regions, as you remember, showing you that the sea level is rising almost all over the global oceans. And I mentioned the hot spots where, unfortunately, along the U.S. eastern coast, where the sea level is rising 3 to 4 times larger than the global mean average. Similar hotspots we see in the Pacific Oceans and Indian Oceans. So that's the picture today, and with Sentinel-6 we would fine-tune those numbers and potentially tapping into emerging acceleration, second derivative, if you will.
Thank you, Nadia. Philippe on Twitter comments, "It's the little house in space. Why is the spacecraft shaped like that?"
So I can maybe comment on that a little bit. So, you know, as we've been discussing about these series of missions, we always have a challenge to continue the measurement and do it very, very precisely. And so we have a combination of using heritage technologies and things that are tried and true, and then augmenting those with enhancements as we go through going forward. But you know, the ESA program really selected a very robust satellite platform built by Airbus. It's a tried and true architecture with a lot of heritage from the prior missions like Cryosat. So this particular structure and form factor that you see is built on a lot of heritage that ESA and Airbus have utilized in prior missions. Of course, very much tuned for our particular mission, needing lots of stability, accuracy, and pointing control. So you see the structure on the outside. If you go back to other satellites like GRACE, which was one of the NASA programs, or Cryosat, you'll see a lot of similarity. But really what you don't see is what's really embedded in all of the satellite with the technology that's specifically for this particular application. But that's where that particular architecture comes from, and we're really proud to be able to build on the successes of these prior missions.
Thank you, Parag. Sky Phoenix on YouTube asks, what does it take to work for NASA or ESA? Dr. Z, would you like to take that question for NASA? And possibly we could get Joseph then to answer for ESA?
That's a great idea. I'm happy to talk about this. We have a series of very talented individuals that work at NASA and very diverse. Many people from many different backgrounds, different accents, different parts. And really what we're looking for are people who are just like us, very committed to working on these important projects. Frankly, this is not for everyone. You have to really look at yourself in the following sense. It takes patience and it takes a lot of teamwork. The one thing that's really important to know, even though the amazing engineers and scientists that are here on there, we all recognize that the only way we can do a project like this together is as an integrated team that brings together all these different perspectives. We're looking at most of our employees at NASA have STEM degrees, as they say, you know, science, technology, engineering, and mathematics. But make no mistake, we have individuals with many different degrees. For example, some of the artwork here was done by artists. Some of the writing was done by English majors, and so forth and so forth. So what does it take to work at NASA? A real desire to do so, and a dedication to want to work with teams that really do amazing things. But I'm interested how you would answer that, Joseph.
No, thanks, Thomas. I think you have said it all, so there's not much to add because NASA and ESA are working in a very similar fashion, and we have very similar talents. I think you really need talented people. We have the luxury of having a good selection of being able to take some of the best engineers which we have in Europe. ESA has, as you might know, 22 member states, and we are having most of our people from these 22 member states. So you need talent, you need a lot of dedication, a bit of craziness, because there are things that we are doing not always in the norm, but a bit outside the box. I think you have to be ready to do that and go a bit beyond what normally you would be doing as an engineer. And a bit of luck, I should say, because there's always opportunities coming up, but they don't come every day, and they need to be, as always, on the right place at the right time. So, but ESA and NASA, in this sense, we are really like brothers and sisters, and we have a very similar workforce, which I think is quite unique, and that's the best asset we have.
Thank you, Thomas and Joseph, for that. We have Stephen Clark now up from Spaceflight Now with a follow-up question. Good morning, Stephen.
Thank you for taking another question. I was wondering if the various partners can discuss their financial contributions to this particular mission, Sentinel-6 Michael Freilich, and a total cost for the mission if possible. Thanks.
For NASA, I'm going to start. It's kind of the investment for both of those spacecraft is of the order of $500 million. I'm going to turn it over to ESA, Joseph.
Yeah, no, in fact, in the European side, it's exactly the same size in euros. So we have the same investment on the European side. In Europe, we have three main funding partners, the European Commission, the European Space Agency, and EUMETSAT, in different shares. They're not exactly the same amounts, but these three organizations have contributed on the European side. But I'm very happy to say that the U.S. contribution is the same size as the European contribution. And in fact, the naming of the satellite is also a good balance, and I think that shows that we are well aligned and we work well together in a very true partnership.
Thank you again to Thomas and Joseph. We're going to go back to social media questions right now. Emerson on Facebook asks, what is the level of measurement accuracy of the sensors?
So I could start, and maybe Nadia can complement for that. So first of all, you know, as I mentioned before, you know, we have a job to do two things. One is guarantee continuity. So our overall measurement objectives are built upon the prior JASON series missions, but it's not just to take the same requirements that we've been building on, but our existing satellites like JASON 1, 2, and 3 actually have outperformed their requirements in flight. So we're actually benefiting from their in-flight performances. And so on Sentinel-6, we've basically reset the requirements to be more in line with what we're actually seeing in flight from the prior missions. The numbers don't change dramatically because we're really talking about small numbers. So if we're talking about 3.4 centimeters, we might be going down to 3 centimeters. But that is critical, as Nadia mentioned, when you're looking at really small features and small scales. We're doing that with the altimeter, with improved accuracies. We're doing that with and extending it with higher resolutions in faster data turnarounds also. This is an operational mission, as has been said before. So getting all of that data, accurate data, down to the ground, processed, and turned around to the community within 3 hours, and doing that basically 99% of the time, 24 hours a day, 7 days a week, is part of that enhancement. We're also trying, particularly on the NASA instrument, to improve the stability. So having this augmentation where we can guarantee continuity on one hand, but enhance the capability on the other hand for now and for the future. This sort of stability measurement really took us months, if not years, to look at collecting data, processing data, averaging data for a long time, and we're expecting to shrink that time cycle. So part of the improvement always isn't in the exact accuracy, but it's also in the time scales that we're talking about, and being able to turn that data around and having it more useful to the scientists faster and reliably. Maybe Nadia wants to add.
Thank you, Parag. Well said. Perhaps I would only add that the way we deal in earth science, we take multiple repeated measurements. We also average them over the same time and space. So over the global mean, you would get those millimeter accuracies because you're averaging a larger number of repeated observations.
And Nadia, this probably will go to you as well because it's a related question. Russell on YouTube wants to know, will the satellite be sensitive enough to capture rogue waves?
Rogue waves, well, they're high enough. You don't need a lot of accuracy. So if you are lucky enough to catch them between the 10-day repeat cycle that they passes, sure.
And Camellia on Facebook asks, as a teenager, how can we help on this project?
I'm going to start, but I'm really interested in what Karen is going to say about that also, perhaps others as well. You know, I have to tell you, as a teenager, you know, I'm a scientist and I'm an astrophysicist, so I tend to look away from Earth, even though I live on, and I know now, on the most beautiful planet ever observed. We have thousands of those now from around the galaxy. And, you know, what we can do as teenagers are really two things. So first of all, it's like there's amazing work out there. NASA is putting out lessons, they're putting out movies, is putting out books, and many of our partners, you know, in various locations are really telling the story of nature. Go focus on that, be interested in that. Every once in a while, we have programs, and there are some that are focused on earth science and actually even on the ocean that are what we call citizen science programs. So it's really science projects that you can participate, perhaps with your friends or parents, to really engage into one of those elements. And frankly, citizen science is really powerful. We have discoveries that come from citizen science. And so you know, find out where those opportunities are and get involved. I have to tell you, there's no age that's too early to get started to do this amazing work, getting to know our planet and really actively participating in doing research. But Karen, how would you answer it?
Thanks, Thomas. I would just expand a bit on what you said. For decades now, NASA has been putting or making our data available, just, you know, to enable, of course, scientific collaboration around the world, but also to make it available for citizens, for students to explore themselves. So I would say yes, absolutely. NASA has a lot, and also our European partners. We have websites that you can explore and learn the science as we do. Really, we write the stories of what we learn and post them very quickly as we're learning, so you can follow along with us. You can explore the data yourself. As Thomas said, we have a variety of citizen science activities. One of them just closed, the annual Space Apps Challenge, where we throw challenges out, and people around the globe form their own teams and come up with their own solutions. And then I think the last thing I would say is come join us. You know, really focusing on STEM in your education will, but not exclusively, as Thomas said earlier, but focusing on your education and coming to join us, because there's so much more work to do ahead of us, and we're going to need the talent, the enthusiasm, and the perspectives that you'll bring to our teams as we move forward. Thanks.
Thank you so much, Thomas and Karen. And it is our future generation, so please apply. I'm sure everyone across the board with our European partners also have internships. So definitely make sure that we impress that upon our future generations. So thank you so much for all of your questions, and thank you to our panelists for joining us today. If you want a replay of all of the graphics that we showed in today's program, that will be replayed right now until the end of the hour. The U.S. European Sentinel-6 Michael Freilich satellite will launch from Vandenberg Air Force Base no earlier than November 10th of 2020. For more information on this satellite, go to nasa.gov/Sentinel-6. You can also follow on all social media platforms at NASA Earth to keep up with this mission and all the Earth missions we are a part of. Thanks so much for joining us today. At NASA Earth Science, your home is our mission. Thank you for watching.
This is this big, complex machine that we're trying to understand.
We really need to understand how it's changing. How is it evolving?
Wherever you live on this globe, the oceans will influence you in some form or the other.
We are answering those really interesting and hard questions that we all have about our universe and our planet.
And my name is Séverine Fournier, and I'm observing our changing oceans from space.
I'm Shannon Statham, and here at NASA JPL, I help prepare Sentinel-6 for its journey to space.
My name is Shailen Desai.
My name is Parag Vaze.
My name is Ben Hamilton, and I'm studying sea level rise from space.
We're looking at a 1/3 replica of the Sentinel-6 Michael Freilich satellite.
Sentinel-6 is all about water. This sort of top half of the satellite houses the main instruments.
We have the altimeter, we have the radiometer.
Sentinel-6 is a collaboration with NASA, NOAA, the European Space Agency, and also EUMETSAT in Europe to measure sea level.
And it's specifically capturing the height of the ocean.
The satellite is actually emitting a signal.
And that signal is bouncing back.
It measures the time it takes for that pulse to get back.
So we've been measuring the height of the ocean since the beginning of the 90s.
I've worked on Topex Poseidon, JSON-1, JSON-2, JSON-3.
We really need that long duration observation,
and Sentinel-6 is going to allow us to continue that record
so that we can better predict what is the rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It's not just scientific curiosity, it really impacts the daily lives of people and their ability to plan for their future.
I see pictures of coastal inundation and flooding.
You start to realize the importance of understanding what sea level is doing now. We can use that understanding to know what sea level might be doing in the future.
Seeing that come to fruition is a personal satisfaction and an emotional satisfaction.
Scientists around the world are using this data to help people.
The importance of this project and where it touches is on all walks of life all across the world.
From space, it's just one planet.